This short slideshow will explain how geologists recognize faults. Remember, a fault is a break in the earth along which the rocks or sediments on either side have moved. That movement usually isn't smooth and continuous. It goes in fits and spurts. Faults are important for earthquake hazards because the sudden episodic movements along the fault cause earthquakes. The easiest way to recognize a fault is to see both blocks of earth with the surface between them exposed on a vertical wall of rock. These vertical exposures of rock are called outcrops, and typically only occur naturally in mountainous areas where erosion has created relief. Usually it's pretty easy to recognize a fault on this kind of surface because your eye will pick up some kind of interruption in the flow of features across the fault. If you can see how the features have been offset, you can even tell the relative direction of movement on the fault. Often, road construction creates outcrops, like this example from Arizona. It should be pretty easy to identify the fault in this photo. The second way to identify a fault is to look for a scarp, a sudden change in elevation. Scarps are formed when the movement on faults lifts one block higher than the adjacent side, and when erosion isn't able to make them even again. Scarps are usually easy to identify, even when they're small. For example, your eye immediately notes the change of slope seen here on the flanks of Mauna Loa volcano on the Big Island of Hawaii, where movement along the Helena Fault has dropped the side nearest to the viewer down about 1 meter. Other scarps are huge, but might be hard to identify because the smooth scarp surface has been modified by scour and erosion. This is the case here along the Teton Fault in Wyoming, where a 7,000-foot fault scarp sets off the Teton Range against the floor of Jackson Hole Valley. This block diagram shows the nature of the fault, which, as you can see, extends underground for many miles. The third way to recognize faults is to look for offsets or truncations of horizontal features on the surface. These features can be natural, like ridges or hills, or man-made. Truncations occur when there has been vertical motion along the fault. For example, this line of ridges has been truncated by a fault running perpendicular to its trend, which has dropped the land and severed the ridge. Offsets occur when there is a horizontal motion to the fault. For example, this ridge and stream have been offset when the land closer to the viewer lurched to the left. Here's an aerial view of the San Andreas Fault, in which you can see two streams that have been conspicuously offset by the fault. Humans have made the job of recognizing faults easier in some cases. For example, here is an orange grove where the neat and tidy rows of trees have been shifted right down the middle along the San Andreas Fault. Other man-made objects, like roads and fences, can also provide a good reference for noting offsets produced by faults. Many times the surface expression of a fault, the scarp or offsets or truncations, are not visible because erosion has planed off and covered up the surface. This happens when there's not a lot of motion along a fault and the land erodes faster than it can be displaced. In this case, sometimes the only way to recognize a fault is to note the odd juxtaposition of rocks next to each other on the surface. Study this animation carefully. The fault brings the gray rock up from deep underground, where it's eroded and ultimately sits next to the blue rock. But the blue rock is younger than the gray rock, and they shouldn't be lying next to each other. The explanation is that the gray rock has been uplifted along a fault. Here's an example from Virginia. On this geologic map, different kinds of rocks are indicated with different colors. Notice how the salmon-colored area, which represents young sedimentary rocks, is juxtaposed against the mostly gray, partially red and green area, corresponding to very old igneous and metamorphic rocks. This juxtaposition occurred because of motion along a fault, indicated by the black line. Sometimes erosion and deposition on top of the surface of a fault can make it completely invisible. This can happen to any inactive or slowly active fault. Here's what a fault scarp might look like a few thousand years before it's completely erased by erosion. There are some faults that just can't be recognized from the surface. For these, the only way to know if they're active is to locate the earthquakes they produce. So the last way of recognizing faults is by earthquakes. This is obviously a little backwards because the whole point of identifying faults was to assess the earthquake risk they pose. But if earthquakes are the only way you can identify a fault, so be it. A great example was the 1987 Whittier Narrows earthquake in California, which caught geologists completely by surprise because they didn't think there was even a fault there. When seismologists plotted the locations of the earthquake and its aftershocks, they found that the earthquakes clustered underground along a plane that they later interpreted as the fault plane of the Elsinore Fault. So, in summary, there are 5 principal ways geologists recognize faults. 1. They can observe rocks offset from each other on vertical exposures of rock called outcrops. 2. They can recognize scarps, which are places where elevation changes suddenly. 3. They can observe offsets or truncations in linear features on the surface, such as ridges, rivers, or even roads and fences. 4. They note places where dissimilar rocks are juxtaposed next to each other in a way that can only be explained by faulting. And 5. They can locate the earthquakes produced when rocks slip along the fault.